Hey there. Today we're going to build this little sprite editor in J. It's pretty rudimentary as far as graphics programs go, but you can load and save files. You can draw in different colors with the mouse. And you can even customize your palette as you go along with this little system dialog here. More importantly, we're going to cover everything you need to know to make interactive programs that respond to the mouse and keyboard in J. All right, so let's get started. Now, pretty much whenever I write a GUI program in J, one of the first things I wind up doing is writing the close handler for the window, and then invoke it to clean up any old versions of the window that are lying around. Otherwise, you have to manually close the old one every time you rerun your script. So here my window is named GPW for GridPad window, and when I click this little X button, J is automatically going to look for a function that has the name GPW_close. Now, it doesn't actually close the window unless you tell it to. And that's so that you can put an "Are you sure" message up or save your work or whatever. In this case, all I'm going to do is just select the window with the window driver command. I'm going to say parent select GPW, parent close, and then, or parent means window, and then set the system timer to 0. Then, this bottom line here, it says call this function this many times. So this is the power conjunction that says how many times to run something, and WD is parent gives you a 0 or a 1 telling you whether or not there is a window open called GPW. So right now we do have a running window named GPW. So if I run this code, it'll close that window. I should explain that I'm doing something new this video. This window right here is a little presentation tool I made that's also running in J. I've got a button I can press to run whatever code is on the slide. I'm hoping it's still going to feel like a live coding session, but without all the typos. Maybe I'll talk about how it works in another video, and in the meantime, I'm just going to press the button here and run this code. Okay, so the window disappeared, and this line at the top erased all the definitions that were in my J session. So now the only word that we have defined is the close handler because it was defined afterward. Okay, so let's get started building our simple sprite editor in J. All right, so we have a bunch of window driver calls to set up our window. I covered most of this in the last video on basic animation, so I won't repeat it here. The main thing that's new is that I've got multiple controls in the window here. So I'm using this bin command to group them horizontally and vertically. So now when I run this, I get a blank window. There's no menu bar yet, just space set aside for the palette, which is going to be this section over here, and the canvas. And then there's at the bottom here a little tiny status bar that you can just barely see. So now we need to tell it what to draw. Again, I covered this in the last video. We're going to import viewmat and define this little function called vmcc that calls viewmat and invokes it inside of a child control. The difference in this video is that now I'm also passing in the parent control name. So I'm passing in 3 arguments instead of 2. And that's so we can select the window we're working with. In my case, as I said, this presentation window is also running in J inside my session. So I need this to tell it which window to draw the thing in. If you only have one window, you don't really need this deselect step, but it's probably a good habit to get into. Okay, so when I run this code, nothing is going to happen on the screen. It's just defining this new verb that we now have to work with. So let's actually call it. Again, GPW is the window name. IMG is the name I gave to the canvas control. And image is this 32 by 32 matrix that we're going to be editing. So now I'm just going to do the same thing that I did in the animation video, which is to call this render verb every 100 milliseconds. This is kind of wasteful because we're not really animating here, but I find it kind of convenient. Now, the alternative is to explicitly repaint each time we make a change, and that's probably the right way to do it if you're not going to be animating. So we'll do that way when we draw the palette. But when I run this, there's our beautiful artwork. All right, now to draw the grid, we'll add these lines right here to our render function. The shape of our image gives us its height and width. The image height, image width. And then we are going to select the image control and use GL query width and height to get the viewport width and height. If we divide the viewport into this many chunks, we get the size of the cell. and we multiply that by the numbers 1 through, or 0 through whatever the number of pixels are. This gives us the locations of the lines. And then for each one of those, we're going to start with that number at the left and that number at the viewport width, so all the way to the right. And then just in case we pick some numbers here that were a little bit off, we're going to round that. So add 0.5 and take the floor. Then this gives us all at once the entire set of horizontal lines. And then we do the same thing for vertical lines. The only trick here is that we want the height, the height of the window, to be last thing in the list. And this is a train, so it has to have a verb on the right rather than a noun like the height. I could have drawn from bottom to top and put the 0 colon on the right over here to make that a verb, or I could have used the double quote operator to make VH a verb, but I decided to just use the tilde to swap the order instead. There's no real reason to pick one way or the other in J. It's just whatever works and whatever you think looks nice. Anyway, if we run this, we're going to get a grid. All right, you'll notice I put a conditional around all this. So let's add a keyboard shortcut so we can toggle this on and off. Each control in a J window has its own keyboard handler. The naming scheme for all of these control-specific event handlers is parent name, so GPW, child name, so here PAL and image, I'm defining this twice, and then the event name, so char for character. Because this is specific to each control, and I want the keyboard handler to work no matter which one of the controls has the focus, the same keys are going to work. So that's why I give two names to the same verb. So the first is the handler for the palette, the second is for the canvas. Pretty much every event in JQT sends its data to us by populating a string named sysdata in the current locale. So when it's a keyboard event, sysdata just sends a string with whatever the ASCII character is for the key that got pressed. Okay, so when you hear that, you might ask, well, what about control characters and alt characters and function keys? But the answer is you usually can't actually trap those at the control level. They're, as far as I know, those are handled by the window as a whole. Okay, so this code should be pretty self-explanatory once you get to know the J primitives. So I'll just run it and show each key. So from the bottom up here, G toggles the grid. So this dash and dot is the sign for not, or 1 minus the thing on the right. R builds a 32 by 32 grid of random 24-bit colors. That's 8 bits each for red, for green, and for blue, which is what pretty much every graphics program uses. Right. And because we're redrawing 10 times a second, holding down the R key shows off the basic animation idea from the last video. It's kind of useless in a sprite editor, but it lets me demonstrate the last shortcut, which is that N resets all the pixels back to 0, which is the color black. It's N for new image. Anyway, now that we have our grid, we want to be able to draw on it with the mouse. In particular, we want to use the mouse coordinates to tell us which pixel in the image needs to change. So the first challenge is to get the mouse coordinates. Once again, we just define a function with the right name, and we get the event handler. So mmove handles mouse movement, and we only care about the canvas this time. Again, sysdata is a string with the information about the event. And this line just tells the window driver to set the label of our status bar, which I called SB, set the text to whatever's in that string that we're getting. The asterisk here is a special syntax in the window driver language that tells it to take the rest of the string and pass it as an argument, unquoted, to the command that we're currently running. Otherwise, we'd have to put double quotes around it, and WD would keep looking for more window driver commands afterwards. Anyway, so when we run this, and we mouse over the canvas, you can see the full string we get for mouse events. Basically, it's the X and Y coordinates on the left of the mouse, the width and height of the child control, and then just a bunch of little flags and numbers that have to do with like which button was pressed. So here I'm pressing down my two mouse buttons. Here's the scroll wheel in the middle, and there's also some flags for like control. Here I'm pressing Control and Shift and Alt and whatnot. But for now, all we care about are the coordinates. So we want to take these first two numbers, which are the screen coordinates relative to this upper left-hand pixel of this control, and map them to indices within our array. Oh, so first we go back to that mouse move handler, and we're going to change the word sysdata to this command whichbox cell size. So this says evaluate the cell size verb, pass in the result to whichbox, and then convert that to a string, which we then pass to the same command we ran before. So cell size is pretty much the same idea that we used when drawing the grid. We query the width and the height of the canvas and divide it by the shape of the image. But the shape on the screen is width and height, but the shape of an array is height followed by width. So we reverse it before we do the division. This is divide. All right, so now this becomes the y argument here to whichbox, which takes the sysdata string, evaluates it to get an array of numbers, takes the first two of those numbers, which was our coordinates, and then divides that by the cell size that we pass in. Again, this is telling it to swap the order of the arguments. And then round down, and then again reverse the order of the two coordinates, because we want the answer to be an array index, not screen coordinates. So let's run that. And now you can see I get coordinates in terms of grid cells. So when I move the mouse up and down, it's the first coordinate that changes rather than the second. Okay, so now we can map a mouse position to an array index. We want to actually update the array whenever you press the mouse button. So clicking to draw. The event handler for mouse clicks is mblup for mouse button left up. So whichbox cell size is the exact same code that we saw on the last slide, except now instead of showing the index in the status bar, we're passing it to this mouse draw verb. And mouse draw is this verb right here, and it just amends the image. So this is amend. And by placing the value for a white pixel at the index that we gave it. So yeah, amend is this curly brace. It's an adverb, which means it takes an argument on the left and produces a new verb. So this right here, this entire highlighted area is a verb that takes its x argument, which is this hex number, and sticks it into the right argument, which is the image, at the given coordinates. Okay, so because J is a functional language, you don't normally edit arrays in place. And so syntactically, this says make a copy of the array that has this change, and then we assign that copy back to the original variable. In practice, J is usually smart enough to know that the source and destination of this transformation are the same. And so if there are no other references to that array lying around, it's just going to do the thing in memory, and it actually optimizes that away for us. Finally, this less than sign right here is telling, it says to box the coordinates that we're passing in. And I'm going to talk about that in a minute. But first, let's run this code. So now, when I click, I get a white pixel. Okay, so let's talk about this. Here's the same basic code. So I've replaced y with the actual coordinates without the less than sign. So 428 is this pixel right here. So what do you think is going to happen when I run this code? I get stripes. So remember, in J, you're always dealing with the entire array at once. In this case, you're passing an array of indices to modify. So it's saying set item 4 and item 28 in this image to this value. Well, the items of a rank 2 array are its rows. So this is saying set all of row 4 and all of row 28 to this value. Sometimes you actually want to specify multiple indices like this. And sometimes you want to do what we're trying to do, which is specify coordinates within the array. So in J, the amend adverb covers both of those cases. And if you want to amend at depth, which is what we're doing, meaning you want coordinates rather than multiple indices, then the answer is to just wrap those coordinates in a box. By the way, if you want multiple sets of coordinates, you can send an array of boxes. That's what the semicolon verb is doing here. So when we run, we get 2 blue pixels here. Okay, so let's get back to our program. Having to click each individual pixel is pretty annoying. So let's make it draw continuously as long as the mouse button is held down. All right, to do that, we go back to our mouse move handler. And the first line is what we were doing earlier to draw the coordinates in the status bar. But now we're going to say if the left mouse button is pressed, also call the click handler. So how do we know? Well, it's just one of those flags inside the sysstatus string. And the left mouse button just happens to be item number 4. Anyway, that's all it takes. So if we run this, now we can draw continuously. But there's a small problem. It's what happens when you drag off the side of the screen. So it turns out that when you drag, this particular control keeps giving you mouse events until you let go, even if your mouse is out of bounds, which leads to an error like the one you're seeing on the screen. So what's happening is that these mouse coordinates are mapping to array indices that are outside the bounds of the array, and we need to test for that. The fix is pretty easy. We just update our mouse draw event with some bounds checking. So we wrap, this is the line we had before, and we just wrap it in this check. Okay, so inbounds is a dyad. The right argument is the shape of the image, and the left argument is the index that we want to check. Basically, each element in the index has to be less than the size of that corresponding dimension, and it has to be greater than or equal to 0. So this whole thing gives us a single bounds check result bit for each separate dimension. And then this part right here inserts the and verb in between each one of those bits. So this is basically the verb all. And with that change, we're able to drag outside and still see the status, but we don't trigger that error. Okay, so now on to the palette. All right, the palette is just a rank 1 array of colors. I happen to pick a default palette that's near and dear to my heart. These are the colors you had to work with for ANSI art back in the 90s. Now, if we want to draw it, we need a rank 2 array. And the comma dot verb makes each item in the palette into its own row, so it renders vertically. Running this defines a handler for the paint event for the palette. But because we didn't have the palette hooked up to the timer, nothing actually happens until we click the window. So now we're going to define a variable called pen to hold our current drawing color. It's just an index into the palette array. And then we're going to update mouse draw. So rather than sending that white pixel every time, we're going to pull the color from the palette. So if I run this, because I hard-coded the pen to be 2, we should get green. Oops. I run it, and there we go. Of course, what we really want is to be able to click on these boxes here, so that's what we'll do next. All right, so this is nothing new. It's the same MBL up verb, except now we're doing it on the palette. And because there's only one column, we only care about the y coordinate, so we take the first item. If we run this, we should be able to click and draw with different colors. So let's see. There's brown, there's some gray, there's some blue. So, also in this last bit here is selecting the palette and causing it to refresh. That doesn't do anything yet, but the point is we want to draw some kind of marker over here to indicate the active color. So let's do that. There's nothing special going on here. We're just calling glrect 3 times to draw boxes. So first I draw both black and white boxes over the current color. So you can see the cursor no matter what color you click on. And then just because the white kind of blends into the window, at least on my monitor here, I'm going to draw a black box around the whole thing. So let's run that. And again, click to refresh. There's nothing really interesting to say about here. This is black 5-pixel pen. Draw it a little bit inset from the coordinates of the chosen color. And then do the same thing with a small white line. So draw a thick black line and then a small white line around the color. And then draw a black box around everything. And again, we're adding this to the paint function that was already there. Okay, so now we can click around and see our color selection. It's still a little bit annoying to have to, while you're drawing, keep moving the mouse over here. And because of that, I want to hook it up to the mouse wheel so that you can move this cursor up and down just by scrolling. So let's do that. Hopefully this is starting to make sense. It's just another event handler. It's called MWheel. And again, we're doing it for both controls. So no matter which one the mouse is over, we want to handle the mouse wheel in the same way. You get the same array of mouse event numbers as the, in sysdata as the other mouse events. The last item in that list is the change in the angle of the mouse wheel. So double quote period executes the string to parse it as an array. The curly colon takes the tail, which is the last item of that array. And then for my mouse, that tends to always, the number you get always tends to be either 15 or negative 15. But we only care about the direction. So the asterisk gives us the sign of its input. So now we have either a 1 or a negative 1, and we can subtract that number from the pen number to move the cursor. This pipe character is the modulo verb, and we're doing modulo the length of the palette. So if we hit -1, it wraps around to the end, and if we go past the end, it wraps around to 0, and then we just repaint. So run this, and now scrolling with the mouse wheel allows me to smoothly change colors, and you can even do it while you're drawing, so you can get some little rainbow effect if you want. Or you can quickly scroll up and erase. Because I didn't implement something like right click to use a different color, which I think would be a fine exercise for the viewer. All right, next up is the file menu. So as soon as we run this, a menu bar is going to appear in the window. So it seems like you can just do this at pretty much any time. There we go. So the way it works, menu pop, it's window driver commands again. When menu pop defines a pop-up menu. You call file, and then menu pop Z is going to end that menu. You can nest those if you need submenus, but we're not doing that here. And then the menu command adds a new item to the menu. Each item has a name, which will correspond to an event handler. So new in lowercase, open, and save. These three are the event handlers that we're going to invoke. The next column here is the text that shows up in the menu. The ampersands give you a hotkey that you can press while the menu is open. And the last column gives you a hotkey that you can press at any time. So remember I said that the control keys are global to the window rather than to a child control. So here's one way that you can actually set these and cause events to happen. All right, so as soon as we ran that, the menu popped up, but it doesn't do anything yet. So now we're writing the handler for the new item. I already used the key press N in the keyboard handler to make the image black. So for this menu thing, I figured I would make it white. So the rule for naming menu handlers is to treat them as buttons. So it's window name, the name of the menu item, and then the word button. So if we run this, then we can clear this thing out from the menu, or by pressing Control N. Hopefully this line is pretty self-explanatory. Take the shape of the image and use it to reshape the color for a white pixel. Okay, the open and save commands both send this MB message to the window driver. MB is short for message box, and it's just going to invoke a standard system dialog box. So let's just go ahead and run this and see what it does. File, open. There you go. So this dialog box is modal, which means you can't do anything else until you pick a path or you hit escape or close the window. If you close the dialog, you get an empty string back, and otherwise you get the path of the thing you selected. So we assign the value to a variable called path, and if the length of the path is 0, we do nothing. Otherwise, we pass that path to the read PNG and write PNG functions or verbs that we got from calling require PNG. One small trick here is that the PNG library is expecting 4 bytes per pixel. You know, we had red, green, and blue. The last byte is the alpha channel, which lets you specify a level of opacity. And if we don't fill that in, the opacity is going to be 0. And so when you open the image in, say, like Photoshop, you're going to get like a completely clear image. It looks like nothing saved. So to counteract that, when we save, we take that image and we're just adding a 255 shifted over 24 bits and filling it into full opacity. Okay, so now we can load and save files, and we're almost done here. The last thing to do is, you know, this is kind of a limited palette, so, you know, if you want to shade your little blue aliens in slightly different colors, then you want to be able to right click and add new colors to the palette. So let's go ahead and do that. So right clicking is just MBR up for mouse button right up. So let's go ahead and just run this, and then I'll explain how it works. So how about we replace this purple with a new shade of blue that we can do some shading here. You know, maybe it's something like that. I don't know. So the way this works is that we set the pen just like we did with the left click. So now we take the color, and then this hash colon function here is very useful. It's called anti-base, and it lets you break a number down into digits in a particular base, or even a mix of bases. So a byte is pretty much like a digit in base 256. So this takes our color, you know, that we get from here, and breaks it down into 3 bytes, representing the red, green, and blue components. Then double quote colon turns that into a string, which we name RGB. And then we pass that string to the message box command. So again, it pops up the system color picker with the color already selected. And then when we're done, just like the open and save dialog boxes, it's either going to give you back a string for a new color, or it's going to give you back an empty string because you closed the window without picking anything. Again, if the result has a length, we're going to do the inverse of what we just did. We're going to parse the string back into an array, and then apply the base function, which is hash dot, which is almost but not quite the opposite of anti-base to get the new color. The significant differences here, we had to pass in 3 numbers because if it's pure blue or something, then the red and green might have been 0. And so we need to explicitly tell it how many digits we have, whereas here we know how many digits we have. There's some other differences with, I think the rank is slightly different between the two. But basically this undoes that step. And then, so now we have a single number that has all 3 bytes packed into the color. And then we just use amend again to stick that new color back into the palette slot we originally clicked on. And then even though the act of closing that window is probably going to repaint the control anyway, we're going to explicitly repaint it just to be safe. So there you go. A very primitive sprite editor written in J. I'm going to post the entire code for this in a link in the description below. So if you have any questions about it or comments about this video, if you like it, didn't like it, whatever, let me know in the comments. As always, if you like this video and you want to see more of it, click the like and subscribe button, and I'll see you next time.